Click the bell icon to get latest videos from Ekeeda.
Hello friends, this is a problem based on media planning or media resources, and here we have 3 or 4 different mediums of advertisements, and we need to decide how to plan out our advertisement in such a manner that the maximum advertisement is made effective or there is a maximum exposure or the overall cost is minimized, either of the two. Let's first read the problem and then try to understand what they have exactly asked us in the problem. A marketing department of average company has collected information on the problem of advertising for its products. So they are bang on. They want to just analyze what is the problem with the advertisement. This relates to the advertising media available. So what medium is available, whether it is magazine, internet, TV, radio, newspaper, whatever it may be. The number of families expected to be reached with each alternative, cost per advertisement, the maximum availability of each medium, and the expected exposure of each one, measured as the relative value of one advertisement in each of the media. So based on these factors, we need to understand, we need to find out, or we need to formulate a problem where it will be decided how many advertisements should be placed in which particular media. We are given a table here. In the table we have 4 different mediums. We have TV, radio, Sunday edition of a newspaper or a daily newspaper, and we have a magazine. And we are given different columns like number of families expected to cover, cost per advertisement, maximum availability, and the expected exposure. And we are given some additional constraints or the limits, like advertising budget is 70,000, at least 40,000 families should be covered. The families receiving messages could be common, but a family receiving 3 messages, for example, would be taken to be equivalent to 3. That means that if the same family watches the advertisement on 3 different mediums, they will be considered as one single family. They will be considered as 3 different families, not one single family. And in case you are placing an ad, and to make it more effective, it will be judged whether how many families are receiving the messages. So if single family receiving 3 different messages will be considered as 3 different audience of people, whereas they also given us that at least 2 insertions be given in Sunday edition of daily, but not more than 4 advertisements should be given on the TV. So there is a limit on each and every factor, and we need to decide how to formulate this as a problem. We have already given a table in the question, so there is no sense in making a question table again or to tabulate it again. We just follow it as it is. We'll make an assumption first. Now the question here for the marketing manager or the media planner is deciding how to allocate the resources for the different advertisement media. At the end of the day, the resources are always scarce, and so therefore people will always like to make maximum or the optimum use of the resources. How that will be done? Let's see. We'll first make the assumption that X1 advertisements are placed on the TV, X2 advertisements on the radio, X3 advertisements on the daily newspaper, and X4 advertisements in the magazines. That will be our first basic assumption. We'll just make the assumption first. Here is my assumption. Under assumption, I will make an assumption that let the media planner decides X1 ads on TV X2 ads on radio, X3 ads on Sunday edition, and X4 ads for magazine. Now comes our objective function. My objective function will be denoted by Z. Here we are required to decide how to allocate the funds for the different advertisements media, and we need to maximize the exposure. There are two possibilities. They can either ask you to minimize the cost, or they can ask you to maximize the exposure. In the present case, the question is silent, so we will make an assumption that they are asking for maximizing the exposure. So let's work it out. First, objective function will be, here is my exposure, 80x1 plus 20x2 plus 50x3 plus 60x4. $80x1 plus subject to, what are our constraints now? We have too many constraints here with so much information given, so be very careful while solving the problem. The first thing they are giving us is that the number of people or the families expected to cover, and here we are given at least 40,000 families should be covered. So we are using the word at least, that means 3000 x1 plus 7000 x2 plus 5000 x3 plus 2000 x4. That is the number of families that are going to get covered under this advertisement. It will be 3000 x1 plus 7000 x2 plus 5000 x3 plus 2000 x4. This is my total families that will be covered who are going to watch the advertisement, and we require at least 40,000 families should be covered. Since they are using the word 40,000, at least 40,000. That's the first thing. So we have got a number of families that are covered, and I have tried to formulate it into LTP. The second thing we are given is the cost per advertisement, and we are given a budget of 70,000. So we'll put down those things here. I have 8000 x1 plus 3000 x2 plus 4000 x3 plus 3000 x4. And here we'll just note down whatever amount is allocated for that particular advertisement. It will become 8000 x1 plus 3000 x2 plus 4000 x3 plus 3000 x4 less than equal to, what's my total budget? My total budget, so the advertising budget is 70,000, so I can't spend more than 70,000 on this aspect. So I'll just note down 70,000 here. This is my budget constraint. The next thing, we have the maximum availability. So my number of advertisements on TV cannot be more than 8. It will be x1 less than equal to 8. Then we have radio. For radio we have 30. For Sunday edition we have 4, and for magazine we have 2. So for radio we have x2 less than equal to 30. And then we have for x3 we have 4, x3 less than equal to 4, and for x4, that is maximum, we have maximum 2. So x4 less than equal to, so this is our basic assumption plus objective function and 4 constants right now. One is for the number of families that are to be covered, cost, maximum ability, and last one is expected exposure. We need at least 2 insertions to be given in Sunday edition of the daily, but not more than 4 ads should be given on the TV. So TV ka not more than 4 ads. So TV का अपना था x1. So x1 should not be more than 4. Then we have, but not more than 4 ads should be given on the TV. Not more than 4 means less than equal to 4. So this will be Sunday edition of Delhi means x3 less than equal to 4, and for magazine we have 2, x4 less than equal to 2. So these are my constraints. Anything else that's pending, let's try to work it out. At least 2 insertions should be given in Sunday edition of the daily. Sunday edition means x3 should be at least 2. x3 less more than equals to 2, but not more than 4 ads should be given on the TV. So TV is x1. Your x1 should not be more than 4. So x1 less than equals to 4. So there are too many constraints here. We had the budget constraint, we had the number of families to be covered constraint, then we had the frequency of the number of advertisements in the various channels. That was a bit complicated, and based on all those things we have actually formulated a problem where we have one objective function and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 different what you can say is constraints of the adjustments. At the end, we don't forget to write the non-negativity constraints. Non-negativity constraints, which will be x1 more than equals to 0, x2 more than equals to 0, x3 more than equals to 0, x4 more than equals to 0. Thanks for watching this video. Do subscribe to our channel Ekeeda.